our natural number to binary representation and the representation of number by base m. So this is how we write our code, and we want to define the basic function, the exponential function, by the limit 1 plus x over n to the power of n when n goes to infinity. So this is a limit of a sequence given by this formula. So let's say an is 1 plus x over n to the power of n. I'm sure you guys are familiar with this type of sequence. So when you think about the sequence, it is a function. It is a function that maps the index n to real number like this. So when you're provided with the x, then you can compute this one by iterating the multiplication. So let's say I want to define x.go, and I'm in the package call again. So I'm going to define my exponential sequence with two inputs. So when I try to compute the sequence with a certain index n, not only I need the index, but I also need the value of x. So that's why I require two inputs, and I want to return the output as this number. And what should I do? So first of all, this is not the correct one. I have result. I'm going to store my result to the variable called result. I'm going to define the value 1 plus x over n as x divided by n as f. And what I'm going to do is just multiply f n times to the result. Okay, that's what I'm trying to do. So let me go through this just one by one. So here I'm declaring the variable called result as a variable of the type float 64. So it's a float type value, and in the same time I assign a value to that variable as 1. And there's an easy way to define a value using this colon equal. So I assign the value 1 plus x over float n as f. And the reason why I use this float 64 n is because n is taken as the variable of type int. And I cannot mix up the two different type in one operation. So x is a type float and n is a type int. I cannot do the operation. So I need to convert the type of n into float. So that's why I'm changing the type. So then what happens is f is considered as the variable of type float with value this much. So and then I'm iterating n times of the following code. I'm taking f and multiply it to result n times. So this is abbreviation of result multiply f. So here, what I'm doing here is I had a value in the result variable. I multiply to f to it and then replace that value to the result. So I'm updating the value stored in the result, and I do it n times. So since I don't want to write down the same name twice, I can abbreviate to star equal. So that's the exponential sequence. And let's check whether it's correct. Here, exp example test.go, and as I said, I can use the example exp sequence. So this is a test function. So I just want to test out what it's going to be. and do the run test. And it says, okay, I got this. So let me use 1 here. So what happens when I input 10 and 1? So 10 is for the index n, 1 is for the float value x. So I'm trying to get 1 plus 1 over n to the power of n when n is 10. So let's run the test. And it says I got this value. So you can replace the output value, desired output value to this, and then run test again. And it says, okay, so what I get is 2.59, something similar to that. Well, I can increase this. So you know what this is going to be when x is 1. When n is large, then this limit goes to the natural constant, 2.7 something. So let's increase to 100. So it changes to 270. So ignore the failing this message here. So I just want to see the result. And how about I increase to 1,000? So now index is 1,000. I want to see the thousandth place of the sequence. Now it gets closer to the actual natural constant. Let's do 10,000, 2.17. And how about 100,000? And getting closer and closer. What you are seeing here is that the computer actually computed the multiplication 10 and 100,000 and million times. So it's getting a bit longer and longer, but you didn't notice. But when I do this more and more, you can see that it actually exceeds the running time if I do this. So now it's taken a longer time. Now you can obviously see. So you need a very large number to put into the index n in order to get accurate result. However, you can simplify this process. So instead of taking an iteration this much time, like 1 trillion time, you can make it simpler. So let's define our exponential function in the simplest way. So I just want to take a number of iteration in, let's say, number of iteration to be 32. So what I'm trying to get is the following. So I define my value to be 2 to the power of n. Okay, so 2 to the power of n. Here, float 64. Yeah, so it's 2 to the power of n. And then I'm going to iterate and this n times. What I'm going to do is I'm going to square this number n times. Must be integer. So here to the float was, yes, bar n. So what is it? So let me make sure that why does it? So let me do this way. So longer way. So I want m to be 2 to the power of n. So I need to multiply 2 to 1 32 times. So for I equals to 0. So I want to multiply m by 2. And then, okay, so here's a longer version of the code. So when I need to multiply, when I need to plug in large number for n, instead of using 10 to the power of something, I can use simply 2 to the power of n. 2 to the power of n here, 2 to the power of n. Okay, so this is my m. Okay, so I can compute my m by taking a multiple of 2 n times. So I choose n to be 32, specific number. And then how, so this is my value f. I stored my value f. And then how do you take the f to the power of 2 to the power of n? You simply squared it 32 times. So you don't have to multiply f to itself 2 to the n times. You take the square and then square that again and then square that again to get the same number. So that's what I'm doing here. So as I said, when you abbreviate like that, it's meaning that f is replaced by f times f, right? So it's replaced by square of the previous value. So it's abbreviated to this. So this way you can compute the sequence with a large index. Like 2 to the 32 is quite large, very large. So let's test out whether it works well. So I want to find a test function again, define test function, and let's see. So I want to find out x1. So 1 is now the value of x. So I just want to find out natural constant. So when I do that, okay, so I got fairly accurate value, right? So with a fairly quickly. And I can also compute x2 fairly quickly, 7.38, something like this. So, by the way, this is not exactly the way the computer is, most of computer programming language is defining the exponential function. So, as I said, in the math package, they define lots of basic functions. So one of them is exponential function. Let's compare two results. So you can consider the exponential function in math package is the most accurate way of finding the answer for the exp of something. So you can see they are different, a bit different. So this second one is the actual exponential value, but the first one is what I just implemented with the 2 to the power of 32. But they are fairly accurate, up to 7-digit decimal, right? So that's enough, I think, for our purpose. We don't want to as accurate as possible. So this is fairly nice way of implementing exponential function. Okay, so we're going to do one by one, and we're going to talk about how to implement exponential function in different way. For example, infinite sequence and series, and eventually, what we're going to talk about, and until the end of this month, is how to draw a graph in the picture, in the image, using the Go code, because you need to know how the image is drawn in order to make a game, because the game is everything. The game is just all about drawing an image onto the pixel image, onto the pixel window. So if you're not comfortable with this programming, I will upload this video into the video and then publish it into the Notion page, so you can go to there, and also just read a book about the calculus I wrote, and you can find out the detail about the code and so on, because I'm just doing the same code that I put it in my book. And also so there is as I said, as I gave you before, there's a reading part, and this is also a small guide to the Go programming language, so you can just exercise few examples here, and if you follow this correctly, then you'll be able to run your game and start making the game. All right, so homework. Just remind you that homework is having a first meeting, which I announced before in the beginning of the class. And also I gave you the 2 pages of the print, right? So we didn't cover the second page, but you should read all the content in the second page, because we're going to cover both pages next time.